Okay, hi everybody. I'm May Terry, a health informaticist from ITER, and I'll be presenting today on transitions of care AI-assisted generation, otherwise known as ToC AI. And before I get started with it, I'd like to give a couple of quick shout outs to some of the folks that made this happen. For the most part, it's a big team of interested folks representing MITRE and the PACIO community, and even some encouragement from CMS. Uh, so, the first question, given all the hype that is around generative AI, is why use generative AI in transition of care? And who is involved? Who is this for? And why does it make sense? We are talking about LT-PAC facilities exchanging data, whether it's acute care to SNF or SNF to home health or home health to SNF. As you may know very well, a lot of the post-acute care environments are still very much in a world where the data is fragmented, inaccessible, potentially never documented, definitely trapped in paper for a lot of it. Sometimes it's not timely. We heard earlier the NCQA person that had measures, right, for transitions of care that, may put some dates on it. So, these are still pain points. And mostly that it's not machine readable or actionable, even though we're improving on interoperability today. A lot of the things that we're working on still reference blobs of text and attachments to it. Moreover, there's quite a bit of irrelevant patient data for certain roles in the LT-PAC environment. Uh, I think in cases where that data is trapped in paper, not necessarily machine readable, we find that as a pattern, generative AI is really beneficial in improving, at least augmenting extraction, some contextualization, and maybe even conversion of relevant post-acute care data. I'm going to give an example. We've had this picture show up a couple of times. It is from the implementation guide of what are we talking about in transitions of care. Honestly, it's a flood of data. There's a lot that could be inside this type of, which has a composition that if you look at all of the things on the top that are in this light blue, are a huge number of sections and underneath it, a lot of types of information that you might find. And it's a deluge, especially considering that some of these are still, trying to populate as much as possible data that's trapped in scan documents. So before we get to that, of what we ended up doing and the demo itself, I want to let you know that we are not necessarily new to trying different generative AI-based applications in PACIO. So just kind of quickly, there's a little bit of prior art. In the past, we had this notion of a PAC app with this thing called Presto, which was able to extract data and recommend or pre-populating some questionnaire items. In this case, it was some of the early parts of or certain sections within the MDS. We also have, and you'll see a little bit of this later today. I think it's still available, which is a FHIR bundle visualizer, which not just parses a FHIR bundle that can be done today by any conventional application, but also looks for things that might be AI tagged or assisted. You will see, potentially not just the, resources that you find, but might have the ability as well to create an AI summarization behind it. And that actually turns out to be used not necessarily just in PACIO where it originated from, but also was tested in the AI Transparency on FHIR track back in last September. And then this one that was shown in the CMS Connectathon number 6 from July 2025, there is a recording of this somewhere, but it was inspired by the patient interest or the patient preferences, whether they are matched against what providers might consider the plan of care for the patient. So in this one, you pointed the application to a FHIR server, it retrieved all those FHIR resources, and not only did a data summary, it was specifically tasked to look for discrepancies where the patient preferences may not necessarily match what the determination was by the provider-based care team. In this example, you would see that there was some mental health advance directive that was originally in PDF that stated that the patient did not want to have electroconvulsive therapy, but yet there were psychiatric notes and even an order for electroconvulsive therapy, and the application found the discrepancy. So, revisiting back our original goal here of what we want to do in applying this to transitions of care, there is an overview, high-level diagram. It's a little technical, but I'll try and put it within the use case as much as possible. Knowing that there's a lot of data that's structured and unstructured, and the goal of what we might want here is to take this huge mix of data and turn it into a TOC bundle because the abstraction behind it is quite a bit of a burden. The workflow might be that the user at the highest level will have a request for a TOC bundle. And not only do that, but we expanded it afterwards. The end goal is that we would end up generating this TOC bundle. If we lift the hood underneath it, what we'll find is in this proof of concept demo, we have further broken apart certain aspects of what is needed to create this transition of care bundle, and maybe even do some further analysis for the quality of the data in this. And the more we started working on this proof of concept, the more we realized that maybe there are ways that we can not only create certain buckets of activities and tools behind it, but we can also potentially make it reusable for other use cases. And the use case then, in this case, is for the TOC bundle. Each one of these is called an agent. So imagine like you have this really smart AI digital assistant that is very tailored to doing specific things. And in this case, it would be starting probably above it with an orchestrator agent that says, first, I'm going to instruct my extraction agent to say, hey, extract for me the following records and pull it from whatever resources, FHIR server or FTP server, whatnot, and extract this data. And then it goes through an analysis phase and a harmonization phase, which is this agent ends up passing it through the orchestrator agent back into a second agent, which is meant to do analysis. And as part of the analysis, there is a tool that does terminology mapping. We use something called Model Context Protocol, which is something that even exists off on the side where you can call a service, and what it does is the extraction will take things from like a document, like a summarization document, say, here are some of the things I'm going to look for. It doesn't have codes on it at the time, but in order to get it to TOC, you eventually have to apply some code. So it will extract certain types of names that are known that might be problems, medications or labs, and then put them into these little atomic terms, and then call this agent for the analysis to find out not only those terms, but trying to map them to US CDI. And we use US CDI version 5 for that. Once it does that, it will take those terms and call out to a terminology database to make some requested codes that may be best fit for that term. And there is a ranker algorithm which would help to determine that if you have multiple matches, the large language model will try and determine what the best term might be. And this happens, you can see that with the analysis and review and the quality checks, it will try and give you the best map. It'll tell you then what US CDI elements are found, which ones are not found. At that point, this content gets aggregated. It gets shown to the user for an analysis, and then there's a transformation, whether you want it to FHIR. Right now, we only support FHIR, but the idea is that we would transfer this, we could transform it to CDA or other versions of standards. Um, but if you see each one of these blue boxes, again, in itself, they could be autonomous agents, right? If I have a whole bunch of records that I want and I want to use this analysis, maybe I could just say, hey, take, whatever I point this to and figure out what the USCDI elements are. Now you can start thinking that with each one of these boxes, wow, I can use them for other applications. And that was our mindset when we started looking at this proof of concept. So, why did we figure, if you look at this block diagram, you figure the transition of care bundle kind of happens at the end, right? If you see this whole workflow, it happens at the end. It's because we realized then that, there's a couple of things what we might want for interoperability purposes. It may be that, you know, transition of care might need to be better aligned with US CDI. And if that's the case, then, it might be better to start saying, well, yeah, let's start saying what we have for USCDI, what we need for transition of care elements, and then after all that, let's combine them together and then put it in the context of a TOC bundle. So we chose USCDI because there is a lot of industry backing behind it. There is regulatory ties for conformance to it. And it would help to make our PACIO work a lot more lockstep with our federal agencies in the overall improvement of healthcare data exchange, standardized healthcare data exchange. And that's what we have in this particular Sakai version. We started with USCDI version 5 because that one is the one that the most current version of US Core, not the beta version, but the release version is aligned with. Let me know if I'm off on that, but that's my understanding. But the design for Takai is such that we can put USCDI version 6 as long as it's in the format that we're looking for, and you could just point it to version 6. Okay. The other thing that we aligned to was PIQI, otherwise known as a Patient Information Quality Improvement Framework. We did this because if you look at US CDI as classes and elements, they don't get down to certain data types. It just basically is this kind of, loose thing of here are the types of elements I want for my patient demographics or medications. There is some guidance in USCDI for what types of terminologies make sense for it, but it's not necessarily tied to individual elements. PIQI gets a little bit, even though it's model agnostic, it does get a little closer to the types of data that we might want. As an example, some of them it will call out as, codable concepts. Others it will call out as a string. But at least it gets you closer while still trying to maintain the model agnostic feel for it. The nice thing about PIQI too is, again, it gives us a framework to start doing analysis of data quality, which is so important when folks are looking at AI solutions and they're always asking, can I trust the data? Is this, am I missing data? That's a difficult one to test, but is this, am I missing something from the extraction based on the source data that I'm given? And is it well formed? So, in that case, having this combination of USCDI and LLMs and PIQI ended up being a great combination for our work. So without further ado, I think we'll kind of get into the demo aspect. Um, You'll see that this is a UI, and it's just a splash page. It's as, all of this is just meant to show and augment what's most important are the services and the back end of what ended up being created as you get towards a request for unstructured data to a TOC bundle. The services are what are the most important because the idea is that if this is good for you, or if you think this is, something interesting to build off of, then you can eventually start just using the agents, not necessarily be tied to, I want to look at this UI and, make this thing color red, make my graphing with dots. That is something that you can do within your own environment. The big power and the most important thing with the problem in that we're trying to identify here is that can we combine this unstructured and structured data in a certain way? And that's what we're showing here. So let me get to open this up a little bit more. Again, this is just a splash page, so you can see what it's about. And in this example, I'm going to select a very simple patient just to show how this looks like, which is Peter Chalmers. This person has one clinical note, and this clinical note is all unstructured. Nothing is structured here. So you can start seeing they have medications and they have problems and they have certain labs that were resulted, from this summary and so forth. So just as a test is more than FYI, I think this is just like a kind of something cute to look at. I added a little chat bot on the side here just to try it. So if I say, what is the patient's name and birth date? What it's doing is that it's going out to the large language model, looking at all the patient artifacts and answering that question and telling you where it found it. So if it says the patient's name is Peter Chalmers. It didn't know that before until it read it. And it said the date of birth is December 25th. And you can see, from the document where it's actually tied to. If I click the run analysis, what it's going to do is it's going to go through this workflow of the extraction of the records and the terminology mapping and so forth. It takes quite a bit, just in general, for a large language model to do that if you have a dense, unstructured document. There could be some optimizations that you could use. But right now, I think for this proof of concept, you'll see that that one document for it to extract took 2 minutes and 19 seconds. And that's because some of it is cached with very common codes for certain terms, and it's dynamically cached. So if you run it for the first time, it's going to take longer, maybe like 4 minutes. If as you start caching the things that it's finding, it's going to run a little bit, take less time. But this one took 2 minutes and 19 seconds. And you'll see what it ended up doing was finding these are for the US CDI elements. I think someone mentioned a while back that there's actually a lot of US CDI elements, 100. In this case, for the version 5, there are 130 elements, and this small example here found 19 of them. If you look inside, what happens is that the proof of concept will create an analysis summary in the form of a JSON. So that way you can, filter it somewhere else afterwards or do some slicing and dicing analysis. But, I, designed it so that it has certain metadata for the overall count, and it'll tell you which ones it found and which ones it did not find. Okay. The other thing that it did was it generated, my version of the JSON PIQI file. So you will see that inside PIQI there are certain classes and elements as well. In fact, it mirrors very much what USCDI has, except it takes it one level deeper. And you'll see that in this case it found things like the patient, the primary language, certain conditions, and so forth. So we show it inside the UI so that you're able to see, in this case, what ended up coming back from the terminology lookup agent. In this case, it found that it was ICD-10. It found certain medications like lisinopril. It identified the vital signs, all of the vital signs that were inside that document. And it also found certain lab results and also tagged them again, knowing that it wasn't, there wasn't any code behind it. Okay. Um, there is in this UI again, uh, while it's showing all of this, the magic behind this is really more the output of these documents because again, these this JSON data can then be reused within your own application, to address the separation of concerns. So now we end up looking at now we have this. It assumes that the user can potentially edit the results. They can save the changes. They can download this whole thing as a CSV. In this case, we want to convert it to FHIR. And once that happens, what it's going to do is it's going to look at and evaluate the artifact of the structure definitions related to transition of care. And there is, in this case, there is a knowledge base that will have the structure definitions or actually look out to the structure definitions that exist for the transition of care, and it will generate. This one will actually be on the fly. So I do convert to FHIR. What it's going to do is it's going to generate that TOC bundle. Let me see if I can find it. No, this is a HighWire Act piece of it. Okay. Uh, so if you see here, and the output. Oh, yay, cool. I think this is it. 1214. Yes. All right. So 1214, this is now the output that I just clicked on, and you can see that there is a TOC bundle that is generated based on the structure definitions in the TOCIG. But looking at JSON is only so effective, right? So here I'm going to reintroduce my little FHIR bundle visualizer that I showed back in a previous Connectathon. And I'm going to point to that latest version. I could also do the point click care bundle. But let me go to the output here and go to Peter Chalmers. And you will see that in this output, this is the TOC bundle with the patient that goes out to the composition, and that composition has all of the related FHIR resources to the composition. I can also see this in a table view where it also shows you all of the references that are made to it and outs that it references to, and all the references that go back to it. So condition has one reference out, one reference in. If I wanted to look at the condition, you can see the raw JSON, but you can also see the AI generated summary. So again, oftentimes when we look at these JSON files, there is a generated summary that perhaps an IG publisher might do, but that doesn't potentially give enough context behind it. By adding an LLM to look at the individual file resource and generate a summary from it, it makes it a lot more user-friendly for a subject matter expert to go, oh, I get this. This patient has type 2 diabetes and it was first identified or diagnosed on January 3rd, etc. You can also do that for the entire bundle. This one takes a little bit more time because it's looking at all of the resources and trying to distill it. But once that happens, you'll see that it'll summarize all of the resources in a very nice text report format. Okay. Um, so any questions on that so far? All right. Um, So we have shown this a couple of times, and it's really been well received so far. Again, it's a proof of concept, so there is quite a ways to go on this. There are technical enhancements, like for example, right now it uses OpenAI for most of for all of the agents actually that leverage the LLM. We want to be able to split this in a way that if you look back at this picture, you should be able to point this to other large language models, or at least support them. And then you can potentially do benchmarking because not all large language models operate the same, right? Their results may be different depending upon which LLM providers and even the version. Other things that we want to do include adding Swagger interfaces. It turns out that in this picture, the terminology lookup is indeed actually a separate model context protocol server. So I can literally run it using Claude Desktop and call out to it, and I just give it some kind of text names, and it will give me the recommended codes. So, if I were to package this together, eventually there may be a mix and match for your application of things that you might want to try. But for this piece, if this piece is separate and running on a separate process, then I probably want to containerize it so that if people wanted to say, "Oh, I just want to run Takai," then I should be able to package it together. Right. Otherwise, they're going to say, here are the prerequisites you should be running, or some kind of script that knows exactly where all of these servers are, and if they're not externalized, and should be kicking them off. So we want to have that, and we want to have some documentation on the interfaces themselves for each of those agents or the potential MCP tools. Again, the containerization and the documentation. And then the one thing I think really is an interesting area, not just for PACIO, but just for healthcare overall, is that a lot of this work that's being shown to you with agents and large language models and its use seem to think that this knowledge base of what exists is just this kludgy mix of a file of a whole bunch of PDFs and text and whatever. And there's some truth to that. But it's also not necessarily optimized to be, quote, AI ready. There could be tests where you have a study, a research study, and that research study or that guideline could be 50 pages. And if your intent is to have many evidence-based guidelines and have it go, "Okay, look for the right one and then answer this very specific question," you have like 100 documents in it, you may not necessarily get the answer that you may think is good because some of these documents may be very similar. Some of them may even conflict. And some of them are just for the sake of performance, probably is better set to take those PDF documents, have it run through a pipeline, and have it in like Markdown or something that makes it a little bit quicker for the large language model to parse through. So this is something that could be best practices of what does it mean to have a healthcare knowledge base. Um, we also want to improve the data quality check. I was very briefly at the PIQI track, but they are continuing with a great interest from multiple organizations on data quality checks and potentially running rules on that data set. And there are certain picky templates that are available for that. It would be helpful if we want to keep aligning with picky to adjust my application to the latest picky templates. And then finally, going back to transition of care, one of the things that has been really explored within our subgroup, our subject matter experts have been pointing out that, we should have some ability to have role-based creation of FHIR bundles. So if, say, I go back to this picture and I said, I want a new transition of care bundle, and I am a behavioral health specialist, then what's to stop this application from applying filters for the types of information or the elements and classes most relevant for behavioral health, going through this whole process and just giving a distilled version of this entire kitchen sink of data that is tailored to behavioral health. And that's a really exciting area, I think, for burden reduction, especially in the distilling of a lot of post-acute care artifacts that we're receiving and all these crazy FHIR resources, it might be very helpful, so that who you are within this post-acute care team will help you to sift through all these documents and give you the things that are most important to your workflow. And I think that is my last slide. Um, thank you very much for listening to my presentation. And any questions?